I've got this backache. I think I'm like punching over my
If stuff
computer
doesn't
all
work,
day.
we can just
In
go
life.
locally and type it out. All right. Hi, everybody. Thank you so much for coming to this workshop. This is going to be put on today by the Developer Student Club at William & Mary. We are basically a group that's supported by Google doing consulting and educator outreach activities. And today we're going to be talking a little bit about NLP and web scraping, which can be really helpful for a hackathon project, like one component of a larger project or whatever. We're going to be using Kaggle for our being able to share the code between us and you. So while we go through this presentation, that might be a good time to set up a Kaggle account. It's free. You just sign up with your school email or any Google email. And that way you'll be able to access our code and it'll go a lot smoother if you don't have to type everything out again. Yeah, so let's get started. My name is Claire Heinbaugh.
I'm Emilio Luzrica, and we are the lead and vice lead for William & Mary's chapter of Developer Student Club.
So first off, what is web scraping? So web scraping is a way to programmatically collect data from websites. Some other methods that people often use in order to get data, like that big data that we talk a lot about in data science so that we can perform analysis, is to use an API. One key example of this would be the Twitter API. So this is where a programmer might try and hit endpoints from an application, so using GET or POST requests in order to get information from, for example, Twitter. So you would collect a large amount of tweets with a keyword that you're looking for in them, and then that is your data set that you can use for analysis. Another option is to use pre-curated data sets. So for example, Project Gutenberg has a lot of free ebooks, which can be really good for historical text, data set text. But if you don't have access to an API or a pre-curated data set, oftentimes your best bet is to go with web scraping. So that's going to be taking stuff from a website and then creating a data set out of that. So oftentimes this is a good method, but we have to sometimes be careful for ethical concerns. So whenever you're getting any kind of data set, you have to figure out what kind of questions are feasible to answer with the data you have. So for instance, if you pull a lot of tweets from Twitter using a hashtag, you might not be able to generalize to answer some like very big questions about different groups, because you could only be looking at like a small subset of what's actually out there, because Twitter limits how many tweets that you can get. And so whenever you are trying to do anything with big data analysis, you want to be careful that you are representing the people that your data represents well. Some of the libraries that we're going to be using today are Beautiful Soup, the Request Library, and Newspaper 3K. These are all great out-of-the-box Python libraries that wrap some of the more complicated functionality of web scraping.
Oh, and just like an extra little bit, there will be a web scraping workshop, I think right after this one, put on by the GeoLab, and they'll go more into it. We're just going to be doing kind of very basic stuff, but if you're really interested in digging into it, right after this, you can check that out.
So web scraping is just to get that data set we talked about, which you can also do with API calls or a pre-curated data set. But once you've actually got your data, then you can do a lot of NLP. So that's just short for natural language processing. So this is essentially trying to understand text, like typically English text or other languages, using code. So some bullet points here just illustrate that. So you can draw quantitative results from text data. We already talked about some possible data sources, which you would acquire already. A lot of these methods are going to use those fun buzzwords that are great for hackathons: machine learning and deep learning. There's also lexicon-based and statistical methods. We'll look at a couple of those in our example code later, and also word embeddings.
Yeah, so kind of once you are set up, you have your data, and you know how you want to attack it. You've kind of decided, okay, I have this data. I need to be able to analyze it programmatically. You got to pick out kind of the methods that you want to use, in application to your data set, to your corpus. And so a couple of common tasks, and these are kind of some of the more simple tasks, although they can get kind of quite complicated depending on how messy the data you're working with is. So Twitter data is obviously harder to work with than maybe like data from a newspaper. But anyways, you can do named entity recognition, and so you pull out kind of what we deem named entities, and that's kind of fuzzy. But basically, what we're saying is, I see a place. Maybe it's Washington D.C. in that text, and I want to be able to kind of identify that that's a place. And so you can do that for people, places. They'll do it for organizations. So maybe Apple, the company that produces iPhones, is mentioned, and so that's one common task. There's also one that I'm sure you've heard of, sentiment analysis, or you can kind of, so that's kind of a higher fidelity method where you might be able to kind of classify sub portions of a text, but maybe you just want to say, I have this big document, I want to know if it's overall positive or negative, so you could do full document classification there. So that has to do with kind of how positive a text is, how negative a text is. You can do topic modeling. That's here's some more buzzwords. That's unsupervised technique. It's an unsupervised statistical technique where essentially you have a collection of documents, maybe they're tweets or something like that, discrete documents, and you want to kind of pull out the words that are kind of most emblematic of what this algorithm is going to deem as kind of topics of the text. And it'll group together these words that it thinks are coherent topics. Semantic similarity is just, I have several documents, I want to kind of compute how similar they are. Are they similar in what they talk about in their content? And so once we have those methods, we can move on to our applications. So, without even knowing it, you have been interacting with natural language processing in so much of what you're doing just in your everyday life. Pretty much all of Google's search engine capabilities are built off of pretty sophisticated natural language processing, and it's just been getting better and better. That's not to say that Google's models don't have some problems, but they are kind of state of the art, and Google puts out kind of state of the art models. Anytime you spell something incorrectly, and I'm awful at spelling, so autocorrect comes in handy for me all the time, and that's kind of a nice little application of text processing. Doesn't require that's kind of more algorithmic rather than kind of a machine learning application. One that's quite fun is geolocation using text. So I have this little figure on the side, and a common application there is, if I have a tweet, I kind of am interested where the tweet came from, and I'm interested in that for a number of reasons. There's a lot of research that's going towards taking the text from that tweet and inferring in some way, from that text and from maybe metadata from the tweet, where was that tweet posted from? And there's a lot of really interesting applied research. It's definitely kind of a very cutting edge field. In terms of the tools in Python, we have some that are kind of geared specifically towards natural language processing. So NLTK, the Natural Language Toolkit, is the super comprehensive library that has a lot of nice functionality for NLP. We have Spacy, which is a little bit more limited, but super fast, and is well documented, a nice API. Stanza, which is like a new kid on the block, kind of, put out by Stanford's NLP lab or research group, and it kind of has functionality built in for a lot of different languages, a lot more support certainly than Spacy and NLTK. And then we have TensorFlow. If you're going to do deep learning, TensorFlow is a great option, and GenSim, which has a lot of stuff for topic modeling, if that's what you're interested in. And so the last slide here, we just have some kind of additional resources, and this is actually posted up on, I believe, in the YouTube live stream chat. Our GitHub site was posted up, and it's right on that. If you scroll all the way to the bottom, you'll find all the resources for this workshop. So if you want to click through to these links, you can do that. But I did want to mention really quickly, Claire and I worked on a hackathon project a couple hackathons ago. Was it for Hoya Hacks? Yeah, Hoya Hacks. And we did some very basic text processing, and definitely in the context of the hackathon project, I personally think that folks find it really impressive when you are able to integrate text processing in some capacity, and even better yet, if it's natural language processing. It looks good, it's cool, it's a kind of a very new thing, and we're going to try to show you how you can use pretty much off-the-shelf tools to do just that. You don't need to do anything too complicated, and you don't need to kind of train your own model. You can get by with off-the-shelf tools and still kind of produce pretty interesting results.
Yeah, so I'm actually going to show you exactly how you can follow along with this lesson, starting with the GitHub website. So Developer Student Club at William & Mary, we have our own GitHub website. We do a lot of these workshops. So if you're interested and this is fascinating, you can look at some of our others, which are on here. So if you go to this link, which is in the chat, thank you, Victor, then you can click on this section is for this hackathon. So we have an attendee version, which is what we'll be filling out together. And then we also have the instructor copy of it. So if we're going through this lesson and you're confused and you get lost and you get a lot of errors in your code, feel free to go through the instructor copy that has clean working code where you can copy and paste or even use for your hackathon project. So what I'm going to do is just click on this attendee version. So this is the code that we're going to be going through today, and we're going to be filling it in. What you want to look for are these fill in here boxes. So Emilio is going to be providing code that will go in here to essentially do some of these NLP processes that we've been describing at a very high level so far. So just make sure to follow along and drop in the chat if you have any questions. I'll try and answer them. So hopefully at this point you made a Kaggle account. If not, you can just do that. And then what you want to do is go to that link. And then over here, since this is my notebook, I don't have it, but you'll have a button that says very big copy and edit. But I'm going to just fork this notebook onto my own, to a new branch, essentially. And so now this is editable. I can also save it and it'll be accessible at any time in the future. I'm going to give everybody like 1 minute to set up their Kaggle account and navigate to that page. And then Emilio is going to get started going through this notebook, explaining some things. And again, yeah, feel free to drop any questions you may have in the YouTube live stream chat, and I'll try and answer those.
Do you want to cover how to get internet set up as well?
Yes. So one big thing that you're going to need to do.
I think it's this guy.
Is it this one? Yes.
Yeah.
So this is if you've never used Kaggle before, just a quick overview. It's pretty simple. It's like Jupyter Lab or Jupyter Notebooks. You have these markdown cells, so I can click here and I can edit it. And then I also have the Python code cells. When you first create it, you can select, do you want to use Python 3, which is what we'll be using today. And you can add new code cells. You won't need to, though. They're already all created for you, and you just fill it in. But one thing, though, is in order to install these libraries from the internet, essentially, you need to make sure your internet is turned on for Kaggle. So if you just go over to the right, you can either click this arrow thing, and you're going to look down here for internet. So since mine is turned off right now, I'll just toggle it on. And now when I run these code blocks in just a second, I'll be able to get Beautiful Soup and Newspaper 3K downloaded. And
if it's your first time ever enabling internet, I think it will have you verify like with your email. It's a little strange.
Or your phone.
Or your phone. It's a little strange how they do it. But once you get it enabled, you'll see that these will run, and these are pretty central to the lessons. These are kind of our scraping libraries. Unfortunately, the Docker image that they maintain for Kaggle doesn't contain some of the libraries that we want. It does contain most of them by default. Yeah. So you just want to, here's something we learned the hard way. You just want to stick to one Kaggle account. If you try and do two and you turn on internet twice, so they're trying to verify that people only submit once to different competitions that they host. And so the way that they verify that you're the same person is with your phone number. So when you enable internet with your phone number, make sure just to use that account, or they will lock you out of your other account. You lose all of your code, which we learned from personal. Yeah, they're not very forgiving about that one. No, and we emailed them. We said, can we have our code back? And they said no. So stick to one Kaggle account.
All right, I think that's enough stalling. So
Yeah.
go ahead.
So let me go ahead and get started. This one, nothing to fill in this one, but this is kind of just us installing stuff that's not Python code. They're just shell commands, and this should kind of start our downloading. It takes a second here. I guess, yeah, it should take a second here. And once we see that it is done, we will be able to kind of run this next block where we import everything without anything erroring. But we can see kind of here that it's still going, and it's still kind of outputting text here as it performs the download. So we'll just have to kind of wait and think. All right, that was not too bad. So now we should be able to run this, and let's just kind of have a quick overview of what we're bringing in here. We're doing Spatie. Spatie is super fast, a lot of nice kind of just off-the-shelf tools. You don't really have to kind of do that much to get good results out of Spatie. Same thing with TextBlob. It has this nice kind of lexicon-based sentiment analysis approach where folks have kind of gone through and for kind of a really large collection of words tagged how positive and negative they are. So that's nice. It's quick. You get pretty good results out of it. Newspaper. It's actually kind of Newspaper 3K, but to Python, it's Newspaper. This is for scraping with news sites, and it works well and kind of wraps a lot of functionality that we would otherwise have to kind of program ourselves with Beautiful Soup. Beautiful Soup is the more kind of general approach towards kind of parsing HTML and different. I think you can do what like LXML and whatever, all kinds of things for parsing a lot of different file types that you would be kind of scraping off with kind of the request library usually. And then just for plotting, bringing in kind of the classics, Seaborn and Matplotlib. Pandas for a little bit of dealing with kind of rectangular data where you have observations and attributes. And just a little bit of NumPy for some extra math functionality. That's enough of that. Make sure as you go that you're running each one of these. If you don't, you'll get errors, and it's a little confusing if you haven't dealt with the notebook format before. So let's go to this first code block. And I already have kind of thrown in here a article URL, and this is our kind of first fill in here. Here we're just going to go ahead and scrape the site's HTML. And actually, Newspaper 3K kind of does this for us. So we'll go ahead and queue up a variable for holding this. Right, we're going to use this kind of article object that that Newspaper 3K has for us. We'll pass it in this article URL that I already have included in the notebook. And then kind of the last thing that we need to do here is say, like, look, we have that. Now please kind of pull it into our environment. And now that we run this, you'll see that I have this print statement, and we'll get a chance to kind of just peek into the HTML and see what we're dealing with. If I could spell. Cool. It looks like nonsense. I can't read HTML. I'm not a robot. If you could read HTML,
That's what a robot would say.
Yeah, I know. Yeah, but if you could read HTML, then we wouldn't need Beautiful Soup, and we wouldn't need Newspaper 3K. We could just kind of do it ourselves. But this looks like nonsense to me. But luckily, kind of Beautiful Soup and Newspaper 3K will kind of shear through that nonsense and pull out kind of the really important attributes. So we instantiate this object, download the article. Where do we go next? Let's go ahead and parse that HTML. I guess I forgot to delete it, but I'll just type it for fun. Article.parse. This method is going to go ahead and parse it for us. And it's going to kind of create a whole slew of different attributes now for, it's going to populate a bunch of these different attributes for this article object that we can now access. So let's go see kind of what we're working with. To note here, some of this metadata is not going to be collected correctly by Newspaper 3K. You kind of lose some of the power of web scraping by letting Newspaper 3K kind of abstract some of that away from you. And so, like, notably, it's not grabbing a published date. There's no published date here. which is unfortunate. Maybe you would want that. We don't need that, but I did want to show kind of some of this stuff is not always perfect with Newspaper 3K, especially. Oh yeah, go ahead.
Can I interject? And that doesn't always mean that it's not there. So sometimes, for example, Newspaper 3K is pulling off of like HTML tags, but sometimes you could actually use natural language processing in order to determine like what is a date. So in a project I did over the summer, we were using natural language processing in order to pull out locations. So even if something didn't have like a published location, we were still able to use NLP to geolocate where that article likely came from. So sometimes these tools, while they're really, like, for example, Newspaper 3K, while it's really nice, it doesn't pull everything out perfectly. And so then you might have to get more into like nitty gritty libraries like Beautiful Soup, or just looking at the raw HTML and performing NLP on that.
Yeah, which can get nasty, but if that's what you need to do, then that's kind of what the tools are there for. Okay, so we've parsed it. Now we're going to get into what we're really interested in here, which is looking at the article text. So let's kind of queue up another variable here, article text. And, we're being really creative with these names. This is just going to be that article object that we already have. And we're going to grab this text attribute, which is kind of pretty intuitive. And then let's also go ahead and print what we have, there. And this one is pretty consistent in terms of how Newspaper 3K handles it. It almost always gets the text, and it almost always gets the text in its full form. So this is one that you can definitely rely on. Cool. So we're looking at this article. What is this article? Let me just flip right back up here. I forgot to mention it. It's a Fox News article about President Biden. I cherry picked an article a little bit, and if you want to click through to it, I have the link there. But I cherry picked a little bit because I wanted to pick something that we could, that wouldn't be entirely neutral, hopefully, in terms of sentiment. And kind of given the circumstances, Fox News and Biden, I think, a priori we can already say, like, yeah, we expect that not to be completely objective, completely objective or completely positive. We expect it maybe to skew negative. So that kind of pushes us towards kind of the results that we're interested in displaying here for this workshop. So, but anyways, we just filled in this bit. What does the text look like? Pretty short article. And if you click through the article, it's grabbing all the text. It's grabbing a few things that I don't know if we really want them, but they're not going to kind of mess with our results too much. They're pretty minimal. So like that, we might not want it. And we could probably get rid of it if we really put in the work. But yeah, it's not going to kind of mess with things too much. So next, we're going to do just a little bit of lightweight NLP. We're going to mess with some name entity recognition from Spacy, and a little bit of sentiment analysis from TextBlob. So here we're gonna I have this kind of already filled in. We're gonna pull in the language model from Spacy, and it comes with this kind of basic pipeline for English. They have a few different kind of ones that you can use. I think this is the small language model, but you can do the larger ones and probably get better results. So in here, we're going to just push the article text that we have now that we've kind of scraped with Newspaper 3K, and we're going to push it through the pipeline. And now it's going to kind of perform a few different NLP tasks and give us kind of some nice attributes in this doc variable that we'll use later. So go ahead and run this. This might take a second. Sometimes it takes a little bit to load that model, although we're doing a small model, so it should take really not that much time. I'll keep that kind of on screen in case anyone's still filling that in. But for reference, these are kind of the different tags that the named entity recognizer in Spacy recognizes that it uses. So we have some pretty intuitive ones. Person, so kind of Biden would show up there. We have kind of GPE, which is what countries, cities, states, United States would kind of show up there. And some of these are not so important for what we're going to do. work of art is generally, something that I don't think many people will use. Percent, same thing. But anyways, there are kind of a number of tags that it uses for its named entity recognizer. So we're going to go ahead and see kind of what named entities we have and pull them out and store them in this named entities dictionary. And we'll also print them out as we go. So we're looking at every entity in doc.ense, which is this attribute that contains all of the entities that Spatie found. We'll go ahead and fill in this block. Label is one of these. So for each entity, it comes with a label as well. If we haven't seen this label before, and it's not in our kind of named entities dictionary, then let's go ahead and create a list for that, and we can start storing the named entities that that kind of pertain to that label, so that we kind of keep track of it as we go. So keep a list open for that, and we don't want to kind of overwrite what we have already. And then we will go ahead and say add that, right? Add that one that we're looking at currently, right? So in the kind of container for that label, let's go ahead and append in. Go ahead and append in our current entity, and so now what we'll have is kind of this list. That's the keys are these labels, the ones that I pointed out here, and then the values are these lists of kind of the entities that were pulled out that pertain to those labels. So if I haven't misspelled anything, this should run fine. It does, and so now we can see kind of the different things that it pulled out. So of course, Biden person, that kind of makes sense. Pulls out Georgia as GPE, that makes sense. So this is pretty intuitive, and it looks kind of how we expect. It's probably missing some things. I kind of imagine there are probably more named entities than this, but I can kind of say from personal experience and from research that I've done that it does a pretty good job. It does kind of a reasonable enough job. So we have this named entities dictionary. Let's go ahead and kind of plot some of what we're seeing here. I guess it's nice to be able to kind of just look in and see kind of how many of each category do we have. So we have a little bit of Python magic there, and so we can see. Yeah, I know. Yeah, that's something you'll only ever see in Python. No other programming language would allow it, but that's what makes Python so special. So person, the person label, we saw 6 named entities of that, and that's pretty intuitive. Most articles, I think you would expect that. Interestingly, we saw work of art labels, which that's pretty sus. I don't think Biden really goes with work of art. So something about the context, something about kind of the context around that particular Biden fooled it into thinking that Biden was something that it wasn't, was the label that it wasn't. And that's kind of a quirk, I guess, of the machine learning technique applied. For the most part, this is pretty coherent. And it's nice to kind of see what we're dealing with. Here, there's nothing to fill in. This is just kind of nasty, and I just kind of did it all myself. We just wrangle it into a Python, into a pandas data frame, and get it looking like we want it to look for plotting later on.
What is a data frame?
Yeah, so a data frame is, so pandas has a lot of nice tools for working with tabular data. And so generally with tabular data, and this is probably kind of a poor use of a data frame, but with tabular data, a common way to see it kind of introduced is in your rows, you have an observation, and in your columns, you have different kind of features of that observation. So for example, you might have a bunch of different people, and your columns each kind of describe some characteristic of that person. And that's how you'll see it described in machine learning, certainly. And data frames are kind of a nice way to just present and work with your machine learning data. I'm abusing the data frame a little bit here because it's really nice for plotting in Seaborn. But yeah, so that's a data frame. This is a little bit of a nasty cell. Ignore it. And just kind of for fun, there's another thing that you can only ever see in Python, is a list comprehension and a dictionary comprehension. I don't know why Python has them, but now that I know they exist, I have to use them. But going down to just our nice little visualization, I kind of just set a couple things with matplotlib, just can increase the figure size. Data viz. Anyways, so then we'll just go ahead and write in, we want a bar plot from Seaborn. And in here, we'll give it a few different arguments that will tell it kind of where to look for our data. So we have this final counts BF, right? Final counts data frame from back up here. So that's the data that it needs to look in. For the y-axis, we'll have it plot entity type. So those are the different labels. Sorry. And then on the x-axis, we'll go ahead and have the count for that entity type. So that's kind of what we have here, and it's going to be displayed visually. And it's just a simple little plot, but it's nice to see things visually rather than kind of in data frames or even in just dictionaries.
I think also, I'm just going to interject, especially with hackathon. So your entire demonstration is basically going to be like displaying front end findings and things like that. And so wherever you can use data visualizations, the sponsors and judges will like you that much more. So you can run that cell then.
Yeah, definitely. Visualizations are things that kind of really make a project pop. We didn't even realize it. We did a project where we did a little bit of visualization, and folks loved it. And we were really surprised because it was basic, It was.
Was it matplotlib?
Yeah, it was just some very basic matplotlib. It was not even the focus of the project, and people just loved it. They thought it was really cool. And it is easy to kind of forget kind of what you're doing with your hackathon project. You get no sleep, and you're thinking about the same thing for 36 hours. But visualizations really make a project pop, and they can be really easy with libraries like Matplotlib and Seaborn. So cool. We just have kind of a visual representation of something that we've already seen. But if you were kind of looking at more data, it could definitely this could definitely make it kind of I could definitely kind of summarize information well. All right, let's move along to the sentiment analysis. I'm going to be using TextBlob for this stuff. Just kind of really quickly, we're going to be using kind of two things from TextBlob, which is polarity, which is kind of sentiment, the real sentiment, how positive or negative is this, and then we're also going to use subjectivity, which is kind of like, is this really objective or is this really subjective? And those are both kind of lexicon-based techniques as implemented in TextBlob. You can do them differently. You can use machine learning for them, but TextBlob does it with these lexica. And so a valence score, how positive or negative, is somewhere between -1 and +1. -1 is super negative, +1 is very positive, 0 is very neutral. And then subjectivity is from 0 to 1. 0 is super objective, 1 is very, very subjective. And so that's kind of just to orient yourself as we look at some of these metrics. So we're going to go ahead and use from TextBlob, this TextBlob object, and pass it our article text so that you can kind of run it through its own pipeline. Each of these implementations has their own pipeline. And if we run this, we should kind of be able to grab out the polarity, positive or negative, and subjectivity, and I have it displayed here. If we want to do something a little bit more interesting, we can go ahead and cut the article into paragraphs, and now we kind of have more data just kind of from our one data source, and so we can kind of look at some kind of more interesting things. I kind of just came up with this off the top of my head, and certainly could do kind of cooler things. But what if we looked at the polarity of specifically the paragraphs where it mentions buy-in versus where buy-in's not mentioned? Are they more positive or they're more negative. I would expect them to be more negative because it's Fox News, but maybe that's not the case for this particular article. So let's go ahead and cut that text into paragraphs. And now you get to do the Python magic with me. If you've never done a list comprehension before, this is going to look super weird. But we're going to go P for P in our article. Article text. Right. So we're kind of going, every paragraph in our article text, although I'm going to do one other thing. Like article text right now is technically an iterable, but if we iterate through each little bit of it, we just get every character of the string because it's a string right now. So I'm going to go ahead and split my article text on new line characters so that now we have it in paragraph form. But we also have to include one extra bit in our list comprehension. So I want every paragraph as long as the paragraph is not just an empty string. And because I'm splitting on new line characters, I'm getting a little bit more than I bargained for. I'm getting kind of the new line characters. I'm getting kind of like extra space where they're, I'm scrolling up to it here. I'm getting this, this extra space here is going to come up as an empty string. And I don't want to hold on to that because it's not going to give us anything coherent when we push it through text blobs pipeline. So coming back down to that cell, we have a little bit more to fill in. So this does what we want it to do. Now we'll go through and iterate through and kind of, figure out kind of what was the polarity, the sentiment score of that paragraph. And kind of keep track of, is Biden in that thing or is Biden not in that thing? So to get the sentiment, we'll go sentiment equals, and then we'll just do kind of what we did above, right? So from the text blob library, we'll use this text blob object and just push our paragraph P through it, right? So kind of one paragraph at a time, and then collect from that this polarity attribute, which I'll scroll up, which is kind of precisely what we used up here to get how positive or negative the text is. And then as we go through this, we'll kind of either put it in one list or the other. Either it's kind of Biden's not present and we'll put it in no Biden sent, or Biden is present and we'll put it in yes Biden sent. We want to make sure that we normalize that text kind of down into lowercase so that we're not kind of confused. We can kind of match this string precisely, and we're not kind of confused by if there's a capital B or if they miscapitalized some part of the word. If we run this one, it should be lightning fast. Everything's super quick here, and we're dealing with kind of very little data. And I'm going to scroll down, keep that on the screen in case you need to copy anything more down there. But then we can check out kind of what is the mean sentiment for paragraphs mentioning Biden and those not mentioning Biden, right? That's just kind of our two lists. And they have, right now, they kind of are holding a bunch of different polarity scores, a bunch of different sentiments, positive or negative. We'll just go ahead and use NumPy to take the mean of each of those lists. So let's print that out. And so this is kind of interesting. For this particular paragraph, the mean sentiment for paragraphs, for this particular text, the mean sentiment for paragraphs mentioning Biden is very slightly negative, but not that negative. Remember, this goes all the way down to -1. And the mean sentiment for paragraphs not mentioning Biden is very, very slightly positive, but kind of nothing very significant. So that's interesting. If you did more articles, maybe you wouldn't find that with Fox News.
You could also potentially go even more granular. So look at the exact sentences mentioning Biden, surrounding words, stuff like that.
Or pull out kind of the words around Biden, and that's something called collocations. And that could be quite interesting too. You could look at kind of the sentiment of those collocated, adjacent words. So the last little thing here, before I hand it over to Claire to show you kind of a more robust example, is just plotting this last. It is just plotting this last little bit, and we're going to do a little bit more magic. We'll go kind of paragraph by paragraph and just grab kind of the sentiment in general. And then we can just do a little bit of like a time series line plot as kind of the sentiment throughout the article, through the kind of the progression of the article. So back with these list comprehensions, You either love them or you hate them. I think most people hate them, but I like them. They are clean. They are a nice way of doing. They can definitely compactify your code. Whether or not they're readable, I don't know. Anyways, we have this the same thing that we've been doing each of these times, and this is going to look kind of weird because list comprehensions get written out of order, out of the order that you would normally do a for loop. But now it will kind of look more or less nonsense as we go. As we go ahead and add this last bit. So essentially, for each kind of object in our paragraph, so each paragraph in kind of this paragraphs container, we'll just go ahead and push it through the pipeline. And then grab out the polarity. And so we'll have this list of polarities that we can go ahead and use Seaborn again for, and we'll use the line plot functionality in Seaborn. And we'll go x equals, and this is a little weird, but take my word for it. It's essentially like range in Python. We'll go ahead and kind of generate here is an index for each one of the paragraphs. And so we'll go np.arange, paragraph, again, go through we want kind of indices for each paragraph. So the length of our paragraph sense, right, which this is the trend that we're plotting. So that's on our x-axis, and then on our y-axis we have kind of that trend that we had pulled out, all those sentiments for each paragraph. And then finally, adding just an additional argument, line width, and we'll set that to 3, and that'll just kind of make it slightly more readable when we plot it. So let me scroll a little bit, but keep that code up there just so you can fill it in as we talk about this. So now we have an index, right? This np.arange is giving us an index for each one of our paragraphs. So that's our paragraph number. And then just the polarity. Maybe you would want to add a 0 line just to be clear kind of where we're looking. But notice that it kind of bumps really negative in the second paragraph. But for the most part, kind of stays pretty close to 0. And that's pretty normal for news sources. It stays pretty neutral. So I'm just going to pause for a brief second and then pass it over to Claire to kind of cover a more generalized example that kind of uses a lot more source texts.
Yeah, I can just talk for a second, just kind of how you would incorporate something this a little bit more into a hackathon project in particular. So the way Emilio and I have done stuff like this in the past would be to create a front end using either like React or JavaScript or Flutter. There's like a lot of options there. And then you could set up a Flask server, which is actually Python specific. So then you can wrap all of your Python functionality into functions, and then you can just hit those endpoints. So we've done in the past where I'll extract text or something from a website, or I'll give him a link to extract text from, and then I'll hand it to him through the Flask server, and he'll accept it on the Python backend, and then be able to do any sort of text manipulation that we need to do. And then let's say you've generated like a nice figure like this on your backend. You can actually store these images. I'm now just giving away all of our secrets. You can store these images, for instance, into like a Firebase database or a SQL database or some other database for file storage. And then you'd be able to just pass back a link, because text is a lot easier to send through servers than entire images. And then that way you could display that image in the front end. So we did that with a Chrome extension that we built where I gave him the link to a page. He pulled out the text, did some sentiment analysis, some NLP stuff on it, and then created a visualization like this. And that's like the one we displayed. And I think, we said the judges really like that. It's really good if you can have these nice visuals. Since Python has a lot of data science specific tools that perhaps other front end languages might not have. So if you're trying to code in Flutter or Dart or something like that, it's really nice if you have a way that you can get your Python to the forefront of your project.
Connecting them up, because Python is really powerful for a lot of things, but for front end it's really not powerful. It doesn't have too many options. Certainly there are some. I think there are ways to kind of create kind of web apps and stuff like that, but it's just, you don't have that same kind of ability to manipulate things like you would if you were actually kind of coding in a real front end language.
I think one time I did a project like in high school. It was with like Tincture. I think that's like a Python visualization library. I don't even know if that's around anymore. That was so long ago. Yeah, so I'm just going to show like a little bit more of a generalized use case. So in Emilio's example, we were just doing that for one article, which is very fun just for demonstration purposes, but in real life, you probably want to pull in a lot more articles. So one just really easy source that I like to sometimes use just for like a variety of data sources would be just to go to, so type in whatever topic that I want to use. So I'm going to do Black Lives Matter, just to go the other end of the spectrum from Fox News. And I can just click that news tab. I'll see that there's a lot of articles here. Now what I could do is like right click on this, and then I could copy this link address, and then I could scrape all the link addresses on this page. But in the name of automating things, I can actually just copy this link up here, and then I can try and scrape the websites from that page. Oh, it's this one. Like, that looks different. So I'm going to create a new variable URL. This is the only thing you'll have to fill in for mine. Mostly we're just going to kind of talk about the code, and I'll get you out of here by 9-ish. So that's my URL to that page. And again, you'll see from Emilio's code earlier, we're going to be using Newspaper 3K in order to extract this article, download, and get the HTML. Then we're going to use Beautiful Soup, which has a built-in function that we can find all these A tags. So in HTML, you have tags that correspond to different elements of the text, so it's a markdown language. So there's information earlier like about pulling out the title or the author. You can look for those tags, or you can even look for the link tag, which is this A. So I'll run this. And this is going to pull out a lot of links because it's all the links in my entire text, and it's super, super long. But that's what it looks like. So then if we were to actually look through this, we can find some patterns which will correspond to which links are actually relevant to our news articles. I already did that for us, but with anything, you can use either regular expressions or like Python's built-in split functions and things that wrap those in order to pull out exactly what you're looking for. It may seem kind of like a lot of work up front in order to figure out exactly which patterns you want to match in order to extract the information you want. But if you're scraping hundreds, thousands of articles, it really does make a difference. So we're going to realize that this substring at the beginning is something that we want to remove, and this at the end. The comments explain that in much more detail. And so we're just going to clean the links up until we get a list that is actually links to articles that we can actually scrape. There are duplicates of each one, which we'll handle later with, you guessed it, a Python set, which will remove duplicates.
It's just us showing off every little
every fun thing
every
about
like
Python.
every unique little thing.
Yeah,
we'll use every single one of
list
it.
comprehension sets, all sorts of fun things. So then this is kind of what I was talking about earlier about how you can potentially wrap some of the tools we've been talking about into Python functions. So you could actually build these into API endpoints using Flask, and then you would be able to just call these functions and then return information. So this is wrapping that entity stuff that we looked at earlier with Spacey. And so once again, I can pass in just the article text, which I already will be extracted a little bit later. I can go through and make that dictionary that Amelia made earlier, and then I can return it. So just to demonstrate that this method works, we always like to write some tests. That's not really a test, that's just a printing test, but you could write a test. So this pulls out get entity, so it pulls out Bob, that's a person, that's right. Here's another thing we're wrapping, so if we're trying to see how subjective an article is, again, that like 0 to 1 value. Oh no, that sounded bad.
I think it's fine. Yeah, I think we're still live.
Okay, we're good. Very cool. So here again, pizza sucks, it is the worst food. That's pretty subjective. And then polarity in terms of how negative to positive something is. I hate everything. That's pretty negative. So I guess the worst, most negative would be -1. So that's pretty bad. So we validated that our methods work, and now we can actually apply them on all of our articles. So I just have this little code block down here that's going to iterate through each of those clean links that I had originally abstracted up here. You'll see I'm converting it to a set now just to get rid of those duplicates. I put it in a try except block just so that I could catch times when it couldn't. Sometimes I can't get the article for whatever reason. There might be, if you're like trying to get something from the New York Times, there might be a paywall, so you can't actually get that article.
And that's kind of one of the, we talked about like ethical considerations with scraping. Like if there is something behind a paywall, maybe, or something behind like a user account, maybe you shouldn't be able to get that information, or maybe you should kind of think twice before thinking like, yes, I need this information, but it's behind a paywall or a user account. Maybe I shouldn't be kind of programmatically scraping this. Sorry.
Yeah. Oh no, that's a good point. And then also a lot of, there's something called a robots.txt file that you can look for, which will actually give rules about scraping certain sites. So for example, the Twitter API, you're supposed to go through their API in order to extract tweets, but they have rules about how fast you're allowed to go. So what they don't want people doing is trying to download all of Twitter or all of a database and then putting it out online free, especially if there's like a paywall. And so they sometimes will regulate how fast you can go. So you can make a request only once every 5 seconds or something like that. So that's also something to consider if you're doing a project that needs a lot of data. How much data can you reasonably get in the 36 hours if you're only allowed to go so fast?
Yep.
So then this last bit, what we're going to do is just pull out each of the articles using those links that we extracted. We're going to get the title. We're going to get the text because, again, that was the parameter that we need to pass into each of those functions we defined. And then we're going to print out the results of calling each of these functions. So I'll just show that right here. Yep, so we can see there's the article title. There's the entities that we extracted as a dictionary, the subjectivity of this article, and the polarity. From here, this wouldn't really probably be the end of a project. You probably want to, again, do some data visualization. So you could potentially take the outputs of all of these entities, and then you could say, like, these are people that are related to the Black Lives Matter movement, or these are places that are really important. And you could plot those, perhaps, like if it was places, you could plot those on a map, and that'd be a really cool data visualization if you had it like interactive or something like that. So this is just a nice kind of like jumping off point to give you the tools to do a lot cooler data visualization front end work. That is all that we have for that workshop. I'm just going to review how you can access the total filled-in version in case you got lost at any point. So again, if you go back to the GitHub link, then there's all of our workshops are linked on here for the entire semester or the whole year we've been a club at William & Mary.
And there might be some stuff here that you want to check out, just like some resources if you're looking for ideas for your hackathon projects. We have some other cool ideas in there. And
all the workshops are recorded, so you can watch them in case you're interested. Also, we're just going to do last little bit of plug for Developer Student Club at William & Mary. If you like workshops like this or you want to get involved, this is our website, and you can sign up for events here. So we have actually an upcoming event in 2 weeks doing agent-based modeling with NetLogo. So feel free to sign up for that. We also do consulting for different groups on campus, so creating apps and scripts. If you'd like to see our app demo from the app we created last semester, it is here. You can watch it on your own time. And yeah, so I hope that helped. Feel free to reach out to Amelia or I with any questions about this or anything else.
We'll try to stay active on the Discord. If you have questions about tools or anything, we'll try to answer them in kind of a timely manner. We're not participating too much in this hackathon, unfortunately. We've done a lot this semester. A lot of hackathons this semester, but we'll try to stay engaged. And if you have any questions, I am on the Cypher Discord. So definitely shoot me a message, and we'll brainstorm a response for you.
So I'm going to stop sharing.